Dear students, I hope you are all well and studying in your home. Today we will start our new chapter, mole concept and stereochemistry, in which only you have to third one in your syllabus. Okay, relation between molar mass and vapor density is given for this year, so you have to read only this and try to understand. But it's good if you go to the laws given related to this chapter, because they are also important if you are wishing to pursue your career in chemistry further. Okay, so first we start with this molar mass and vapor density. So first thing you read here, Avogadro's law help us in determining a relationship between molar mass and vapor density of a gaseous substance. So for this, you have to first aware about the Avogadro's law. Okay. So for this, we have to read Avogadro law also, that what it states: under identical conditions of temperature and pressure, equal volumes of all gases contain equal number of molecules. Okay. If there are identical conditions, it means optimum temperature, pressure, okay, and equal volume of all gases contain equal number of molecules. Okay, so the number of molecules will be same, okay, at optimum temperature, pressure, and volume. So the law implies that the number of molecules present in the equal volume of different gases are equal, provided they are at the same temperature and pressure. That is, 1 liter of oxygen gas contain the same number of molecules as are present in 1 liter of chlorine, or 1 liter of hydrogen, or 1 liter of any gas under the similar condition of pressure and temperature. Okay, when the similar condition of pressure and temperature occur, their number of molecules will be same. Okay, so what are the loss with it number? Okay, the number of molecules of any gas in 1 liter is at STP is 2.687 to 10 to the power 22. This is called Lossmith number. Avogadro's law is an universal law and is valid for all gases, irrespective of their chemical nature. Okay, so there are some applications also. Okay, you can read whatever determination of atomicity of elementary gases. Okay, so these are not very much of from your course. Okay, so you can go through, but just for this I explain you because you get aware about the Avogadro's law. Now we move to the relative molecular mass of a substance is defined as the ratio of the mass of one molecule of the substance to the mass of one atom of hydrogen. Okay, so how we can represent molecular mass is equal to mass of one molecule of the substance, mass of one atom of hydrogen. Okay, mass of one molecule of the substance upon mass of one atom of hydrogen, and molar mass is equal to mass of n molecules of the substance and mass of n atoms of hydrogen. So how vapor density is defined? Density is defined as the ratio of the mass of a certain volume of substance in the gaseous or vapor state at a particular temperature and pressure of the mass of the same volume of hydrogen at the same temperature and pressure. Okay, that is, if you try to calculate vapor density, you have to must mass of a certain volume of a gaseous substance at a particular temperature and pressure. It means only mass of certain volume. Okay, and upon mass of same volume of hydrogen at the same temperature and pressure. Okay, same volume of hydrogen also. So what is the conclusion? That for a substance in the gaseous or vapor state, molecular mass its molecular weight is equal to 2 into vapor density. To understand better, first we read about the relative atomic mass. Okay, in next class we do some questions on that. Okay, or I explain you what vapor density. The relative atomic mass of an atom is defined as follows. Okay, so relative atomic mass of an atom is absolute mass compared to the absolute mass of an atom of a standard substance. Thus, relative atomic mass is equal to absolute mass of an atom of the given substance upon absolute mass of an atom of the standard substance. Earlier, hydrogen was taken as the standard substance, but most of the atomic masses determined with hydrogen as the standard were not whole numbers. Later on, it was found that if oxygen is taken as the reference substance and assigned the value 16 for its atomic mass, the relative atomic masses of most of the elements calculated on its basis come very close to the whole number. For several years, the relative atomic masses calculated with oxygen as standard remained in practice. Okay. In 1961, a new standard C12, the most stable isotope of carbon, was adopted by International Union of Chemists to calculate the relative atomic mass of elements. The new scale adopted is called atomic mass unit. So, what will be the atomic mass unit scale? On this scale, the relative atomic mass of an element is expressed in terms of atomic mass unit, abbreviated as AMU. One atomic mass unit is defined as quantity of mass equal to 1 upon 12th of mass of an atom of C12, most stable isotope of carbon. Okay, so if we calculate according to new International Union of Chemists, okay, so relative atomic mass of an element is equal to mass of an element of the given element upon 1 upon 12 mass of an atom of C12, because now standard isotope is taken C12. Thus, the relative atomic mass of an element is the relative mass of an atom of that element as compared to 1 upon 12 the mass of an atom of carbon. On the basis of this definition, the relative atomic mass of hydrogen is found to be 1.008 AMU, while that of oxygen is 16.0 AMU. 1 AMU is equal to 1 mu, where mu stands for AMU. Okay. One more interesting things comes out from that what fractional atomic mass or average relative atomic mass. The relative atomic masses of a large number of elements are fractional in the form of fraction. This is due to the presence of isotopes. The isotopes of an element possess different relative atomic masses, you know it already. In order to assign a particular value of relative atomic mass to an element which occur along with one or more isotopes, an average relative value of relative atomic mass to an element which occurs along with one or more isotopes, an average relative atomic mass is obtained. Okay, this is done by averaging the relative atomic masses of all known isotopes of the given element in the ratio of their occurrence in nature. For example, chlorine occurs in nature in the form of two isotopes, chlorine 35 and chlorine 37. Okay, you can see their atomic masses are different in the ratio of 3 by 1 by mass. Okay, therefore the average relative mass of chlorine would be 35 into 3 plus 37 into 1 upon 3 plus 1. So average atomic mass will become 35.5. This is why average atomic mass of chlorine is regarded 35.5 mO, or more precisely as 35.45 mO. The average relative atomic mass of an element expressed in atomic mass unit is allowed the atomic mass or isotopic mass of that element. So I hope you will be understand till here what are the average relative atomic mass and how we calculate it, and atomic mass unit scale, okay, relative atomic mass and Avogadro's law, okay, and relative what are the relation between molecular mass and its vapor density. Okay, if you have any confusion you can ask, or it's good if you read about the various gases law. okay, before coming to in this topic. And mainly calculation you have to do in this chapter. Okay, we will do calculation in next class. Thank you.